In this video, we'll continue looking at examples using the law of logarithms. In example 2, we're going to go ahead and use the law of logarithms to expand out the following expressions. Let's start on part A. We're given the log of y raised to the third divided by the square root of 2x. We're going to go ahead and apply the difference of logarithms because we have a quotient here. This is going to be equal to the log of y cubed minus the log of the square root of 2x. In this first term, we have an exponent, and in this second term, we also have an exponent. What we get is 3 times the log evaluated at y minus the log of 2x raised to the 1/2. Simplifying one more time, this becomes 3 log of y minus 1/2 of log evaluated at 2x. This expression here is our logarithm fully expanded out. Let's go ahead and look at part B. We're given the log of the square root of x, of the square root of y, of the square root of z. Let's go ahead and rewrite this using exponentials. This is the log of x, of y, of z, where we have z to the 1/2, then we have y of z to the 1/2, and then finally we have all of this to the 1/2 here. Bringing out this first 1/2, this is going to be equal to 1/2 the log of x times our y of z raised to the 1/2 times 1/2. Since we have that x is multiplied by some number raised to the 1/2, we can use our sum of logarithms, and we're going to get that this is equal to 1/2 the log of x plus 1/2 the log of y z raised to the 1/2, all raised to the 1/2 here. Let me go ahead and start a new page. Here again, we have some number raised to an exponent, and this exponent is 1/2. So we can go ahead and pull this 1/2 out. This is then equal to 1/2 log of x plus 1/4 of the log of y times z raised to the 1/2. In our argument again, we have y times some number, so we can use the property of sums with logarithms to set this equal to the following. Now, to finish this off, again we have z raised to the 1/2 power, so we can pull the exponent out of our logarithm, and we're going to get our final answer, which is our fully expanded log, which is the following. Part C, we're looking at the natural log of ab squared. Again, in our argument, we have the product of two numbers. Using our properties of log, this is equivalent to log of a plus the natural log of b squared. Since we have b squared, we can pull this exponent out, and this simplifies just to be the natural log of a plus 2 times the natural log of b. In example 3, we're going to go ahead and look at the reverse process. Given a fully expanded log out, let's go ahead and use our law of logarithms to combine it into one term. Let's start in part A. In part A, we're given the following logarithm. Let's go ahead and first write all the numbers in front of our logarithms as exponents. Here we have a c, here we have an r that we can go ahead and bring into our logarithm expression. Now, let's go ahead and combine our logarithms by recalling that the sum of two logarithms is the same thing as taking the log of some multiplication. We get that this then is going to be the log base a of b times d to the c minus log base a of s raised to the r. Then we can use the difference of logarithms to combine this one more time into a quotient, which simplifies to be the log base a of b times d to the c divided by s raised to the r. This is our final expression. In part B, we're given the following. Here again, let's go ahead and bring the scalar in front of our log inside. Now we can go ahead and combine the sum of these two logarithms into one logarithm. Then combine these two logarithms as a quotient, since this is a difference of logarithms. Oops, there was a mistake here. Let me go back to this step here. So in this step, this should have been the multiplication. So this is going to be ln of a plus b times a minus b minus the natural log of c squared. And now we're going to combine these to be a quotient.